Hi, welcome to page 3. And what we want to do for this page is talk about the gradient vector. So hopefully you were able to determine, okay, if I'm looking for a direction vector, pretty much what I'm doing is I'm taking the partial of x times it by my unit vector, the component, which is a, plus the partial of, with the partial derivative with respect to y times the unit component for y, which is b. So maybe that might look like something where we took two components, all right, we took two vectors. We have vector of our partial derivatives with the dot product of our unit vector, which we're going to say AB. If we did that dot product, again, it's just the first components times each other plus this, the product of the second components. So what we can do is we can write our direction vector in terms of a dot product where we have, a vector made up of our partial derivatives with respect to our independent variables and u. So one thing that is going to pop up a lot is we're going to be having this vector of our partial derivatives. So this vector of our partial derivatives is going to be called the gradient of f. All right, and we can write the gradient f or have like this upside down delta. All right, so how we refer to that is that's going to be del f. All right, so either we're going to say gradient of f or we're going to say del f to talk about the vector of the partial derivatives of our function. All right, so hopefully that makes sense to you that del f is just the vector of the partial derivatives of our function. All right, here you have it in unit form, and then you also have it in standard basis form. All right, so with this notation for the gradient vector, we can rewrite the expression for the directional derivative of a differentiable function as just the dot product of the gradient of f and the unit vector. So now let's go ahead and use this to answer a question, and we have question 8, find the gradient of f. So again, the first thing we're going to do, we're going to find the gradient of f. So we have del of xy. And again, that's just the unit vector of our partial derivatives with respect to x and respect to y. So the partial derivative of the function y squared over x with respect to x, again, that's x to negative 1, so I'm going to have negative y squared over x squared. So there's the partial derivative with respect to x. Partial derivative with respect to y is just going to be 2y over x. All right, and so there we have our gradient vector. B, we're going to evaluate our gradient vector at the point 1, 2. And so we do that, we're going to get, I'll go ahead and write that out, 2 squared over 1 squared, and then 2 times 2 over 1. And so we're going to get negative 4 and positive 4. And then the last bit, find the rate of change of f at p in the direction of the vector u. So basically find the rate of change. So let's find the derivative, or the directional derivative at this point with our gradient and our unit vector that we have over here to the right. So again, that's just going to be a dot product. So we're just looking for the derivative of our function using our gradient dot our unit vector. And so here, our gradient vector we said was going to be negative 4, 4. And then dot product that with our unit vector. That's in standard basis form, so I can go ahead and say, I can put the 1/3 on the outside, so I'll just do that. 1/3, and then I have 2 and square root of 5. All right, when I do this, I'm going to have negative 4 times 2, which is negative 8. And don't forget that 1/3 on the outside. Plus 4 times square root of 5 over 3. So basically what I have is I can pull out a 2, and I'll pull out a 2 Actually, I can pull out 4. I'm going to pull out a 4/3. So I pull out a 4/3. And I'm left with radical 5 minus 2 on the inside. All right, and there is the rate of change of f at p in the direction of our unit vector. And I'll highlight this. All right, the last part is that, if we have a function of 3 independent variables, what we can do is we can do the exact same thing. So nothing changes if we have 3 variables that we're dealing with. And I'll might give you a few of those to do in notes. And again, the next example is going to deal with one where we have one.